Okay, let me continue. So I hope you have a good result. Last week we already finished these things. We learned about the choroplets, and I would like to continue with this visualization techniques. I think I will just give you a brief review about these visualization techniques. First is we already learned the basic visualization, and we learned about the pixel oriented visualization techniques. The third visualization technique is the geometric projection. It is the visualization of the geometric transformation and projection of the data. The keyword is geometric, and there are some methods on this geometric projection: scatterplot and scatterplot matrices. I think you already know what is scatterplot. And yeah, there can be other methods. We call it parallel coordinates. We call this is the scatterplot matrices. If you still remember the iris data, we have 4 attributes: sepal length, petal length, sepal width, and petal width. Okay. We can see all the plots at once. We can see all the plots with only one visualization. We call this is the geometric visualization. How can we interpret this one? So this is the sepal length, and this is the petal length. So if we look at this box, it means we are understanding this X is the sepal length and this X is the petal length. So all these are related with the sepal length because this is the column. And if we want to see the sepal width and the sepal length, then we can see this box. If we want to see the relationship between the sepal length and the petal width, then we will see this box. So all the scatter plots, as you know, scatter plots are the relationship between two numerical attributes. But we can make it as a matrices. We can make it as scatterplot matrices. So every numerical attribute will be shown at once. Parallel coordinates. In the parallel coordinates, we can see the x. This is the x, and there can be several y. Maybe this is the y1, y2, y3, y4, y5, y6, y7, 8, 9, 10, 11, 12. Okay, so we have 12 other attributes to represent in one x. And we can see this one that in the x equal to 1, there are several values, and this is the maximum and this is the minimum. When x equals to 2, this is the maximum and this is the minimum. When x equals to 3, this is the maximum and this is the minimum. When x equals to 4, this is the maximum and this is the minimum. And we can see the changes. So usually this kind of data is a kind of time series data. So there are some time. Maybe this is the time number 1, time number 2, time number 3, time number 4, and so on. Other visualization techniques, we call it icon base. Visualization of the data values as features of icons. So the keyword is icons. The typical visualization methods are Chernoff Faces, stick figures. The general techniques, we can use shape coding. Shape coding means we will use shape to represent certain information encoding. Maybe we can use the triangle. Maybe we can use rectangle. Or maybe we need to use circle to encode the value. Or we can use color. So the color in icons to encode more information. Maybe the red color, it is more dangerous. Green color is more safe. So this kind of icon, you can see Chernoff Faces. It is a way to display variables on a two-dimensional surface. We can have this two-dimensional surface. Let's say X is the eyebrow. X is the eyebrow. And let Y be the eye size. And then Z is the nose length. This is nose. So different structure or different shape, it will show different values. And the figure shows faces produced using 10 characteristics. So if you have like 10 attributes, okay, you can use this kind of visualization. For example, this is head eccentricity. So the head is like this one, and the head is like this one. It represents different values. Eye size. The eye is oval like this, or eye is oval like this. It shows different value. Eye spacing. So the eye space is far, but this eye is close. Okay, so it has different values. Eye eccentricity. So the eye is small like this one, and the eye is big like this one, or the eye is big like this one. So it shows different value. Pupil size. So here is using very small dot, but here pupil is very big because the dot is a little bit black. Eyebrow length. So the eyebrow, it is just a horizontal, but we can see there is a slope. Okay. So it shows also different value. Nose size, mouth shape, mouth size, mouth opening. Yeah, it represents a values, and they can show it into this kind of figure because this is the Chernoff faces. If you want to find out more, okay, there are some reference about this Chernoff faces in the book, The Cartoon Guide to Statistics, or some ways to represent this the Chernoff face from the Met World or Wolfram web resources. Another way to use the icon is the stick figure. The stick figure, it shows a census. This census data, it shows the age, income, gender, education, and etc. in one visualization. So the data item, it is like 5 stick. So 5 stick means the one body and 4 limbs with different angle or length. So maybe the body is like this one, and then there can be limb. Okay. 4 limbs. This one, maybe this one, like like this one. Okay. So the two attributes map to access, income, and age. So this is the income, and this is the age. And the remaining attributes map to the angle or length of limb. Let's say this limb represents the education. The longer you have the education, maybe the longer of the limb. This limb maybe represent the gender. If your gender is male, it shows in this direction. If your gender is female, maybe it shows in the different direction, and so on. So we can see all of the things at once with this stick figure. The higher income, it shows the higher age with some patterns, maybe the education or the gender that can be represented in this stick. There are another way to do the visualization. We call it the hierarchical. The hierarchical, it means we want to partition visualization of the data using a hierarchical partitioning into subspaces. So the methods, we can use the dimensional stacking. We can use worlds within worlds. We can use tree map. We can use cone trees. We can use info cube. But I think I will just skip this one. Let's discuss only those three. Dimensional stacking. What does it mean by dimensional stacking? Let's say I have two attributes. The attribute 1 and the attribute 2. Let's say this attribute is maybe city, and this attribute 2 maybe season. Okay. So I want to know the temperature at a particular city in the particular season. I can have the values here, and I can expand into the detail of the attribute. Let's say in the, maybe for the Korean, we live in Yongin, okay? Yongin city. And in Yongin city, we have gu, dong, up, or yeah. So something about the district, smaller district. In Yongin, we have Choin-gu, Suji-gu, Gihong-gu. Then it is the smaller attribute. Okay. We can say, okay, I want to see the district of Yongin. And let's say the season. We know we have 4 seasons: winter, fall, summer. Okay. Let's say I want to see the temperature only on summer time. But I want to see not in the summer, but in the particular months. We know summer is in June, July, August. Then we can make more detail on the attribute 4, June, July, August. So we call this is the dimensional stacking. We can make more details on the certain attributes, and we call this is to find the subspace. So we can partition the attribute value ranges into the classes. The important attributes should be used on the outer levels. So we have the outer levels like the season and the city and so on. Another example of dimensional stacking is this one. This is the visualization of oil mining data. Oil mining data in the geography or the earth. We have the longitude and latitude. Let's say this is the latitude and this is the longitude. And if you look at the blue color, it shows that the oil in that area is higher than the other area. And you can look at this particular area. Yeah, we can see there are a lot of oils on those particular areas. So if you want to mine the oil, you can focus on that area. This area has less oil. This area has a very small oil. So yeah, we can mine those areas later, and we will look into the details of those areas. Yeah, we have this dimensional stacking. If I want to look at this detail, this area, then you can focus on this, which location of this area, and then what kind of devices that you need to use for mining the oil, and so on. We can make the words within words. It is in Korean. Maybe for the foreigners. Yeah. Let's say we have the x1, x2, x3, x4, x5, and etc. The x1, one new currency. Okay. The currency rate. And then the x2. Is GDP. And then F is the function I want to see about the sales. So we can see if I know the data about the current currency, and then I know about the GDP, what is the function to see our sales? And we want to see whether there is an effect about another variable. Let's say this is the inflation rate. And then we have export. This is price index. And so on. So if we want to see those relationships in one graph like this one, then yeah, this is one of the representation in words within words. We have the function f, we have the x1, we have the x2, we have the x3, we have the x4, we have the x5. Yeah, we can extend as much as variables that we have. So using this one, every of the variables express to affect the function. The function is very dynamic according to the variable. So we call this is the N fission. It's dynamic interaction through the data globe and the stereo display, including rotation. So we can rotate, or we can scale. Okay? We can make a deep view on the particular values, or we can translate, or translation inner and outer. This is just an example of words within words. There's another example, we call it tree map. In this tree map, yeah, this is an example how we can distinguish news. Let's say the red color here, it represents the words, and then the orange or almost yellow color, it represents the nation. The purple represents business, and then the green represents the technology. The green to yellow is about sports. This one is about entertainment, and the purple is about health. We can distinguish based on the color, and we can make a tree. The tree will be based on the popularity or the importance. Let's say this one, based on the news anchor, this is the most important news. The Pentagon denies this creation. So it shows in the big font. But the other shows in the small font. Maybe this is not that important, but there is a news about it. We can also make a distinction on the particular attributes. For example, we can select the countries. Now maybe it is the news about US. So you can select, maybe I want to see news in Austria or in Canada or France. So this is the news map in the Google News Stories in 2005. And we can still use this relevant visualization for this year. When we are dealing with the complex data, and we want to see some of the relation, we can use also the same visualization. In this case, when we are dealing with the non-numerical data, if we are dealing with the non-numerical data, it is complex. The non-numerical data, we can see it as text. Text is a type of the categorical, but usually text is more than the categorical. The categorical is very small, distinct values. But text, there are many values. Social networks, we want to see the relationship between one person and another person. And if, let's say, you use Instagram, or if you use Facebook, or if you use any social media, you will have text. You can visualize the user-generated text. When you post something, and then you want to see how many person posted using that text. So Twitter have daily visualization, which is the most popular text. The importance of the tag is represented by font size or color. And besides the text data, there are also methods to visualize the relationship, such as visualizing the social network. This is another example. We can see the thesis relationship. This graph was taken from the disease influence graph of people at least 20 years old. There's a data set, they call it this NHANES. So this is the disease name: high blood pressure, allergies, overweight, high cholesterol, arthritis, trouble seeing, risk of diabetes, and so on. And there is a relationship between those diseases. And the high or the big circle means there's the risk, high risk for the person. Okay. Let's say we have this one HP. HP is the high blood pressure. Okay, there are many people in the 20 years old, they have the high blood pressure. And there is a relationship between this high blood pressure and, let's say this is HC. What is HC? Oh, it is the high cholesterol level. So using this simple graph or simple network like this, we can see the relationship between the diseases. Not only diseases, but we can also see some kind of relation between person or between university or between organization and so on. Okay, I think that's all about the visualization. Yeah. And for the next 2 weeks, I would like to explain more about the Python code. So I'm expecting you to prepare your Jupyter notebook or Jupyter lab. So last time I asked you to install the Anaconda. Please install Anaconda in your computer. Okay. And the next 2 weeks, I will give you a very simple example Python code using the Jupyter notebook or Jupyter lab. Okay, I will continue to the next. So the next is about the data pre-processing. So I already shared the PowerPoint in the e-class. In this chapter, we will learn the major tasks in the data pre-processing: data cleaning, data integration, data reduction, and data transformation. So those four are the major tasks in data pre-processing. We have data cleaning. Some of tasks in the data cleaning are fill in missing values, smooth the noisy data, identify or remove outliers, and we can also resolve some inconsistency. When we are dealing with the data integration, we want to integrate of multiple databases. Let's say we have the company in Korea and we also have the company in US. So there can be two different databases. We need to integrate those two databases. Or maybe one company use Oracle, another company use MySQL. So we need to integrate to those databases if we want to make a good data analysis. There are some concepts later about the data cubes and files. Okay, we will learn later. And data reduction. So this is also a task in the data pre-processing. Let's say I have 1 million data. And I also have, I can have 1,000 data. So I can reduce the data from 1 million to 1,000. And when I do the analysis, the results are the same or maybe similar. So which data will you choose? Are you going to use the 1 million data or are you going to use the 1,000 data? If the results are the same, then we will use the 1,000 data. We will choose the smallest one because it is more efficient. It's not that big. Because when you have 1 million data, it can consume your computer resources. So we need to learn the data reduction. There can be the dimensionality reduction. How can we reduce? If we reduce it to 1000, is it still reliable or is it still good? And there can be another concept, numericity reduction, data compression. And we will learn about the data transformation. In the data transformation, we'll learn about normalization and the concept hierarchy generation. Okay, let's see the first one, data cleaning. So in the data cleaning, we need to do this data cleaning because the data in the real world is dirty. Data in the real world is dirty. What does it mean by dirty? There are a lot of potentially incorrect data. Maybe when you are collecting the data from the company, the instrument, there are some errors, instrument faulty. Or when you collect the data, some human errors or computer errors. Or maybe because of the internet connection errors. Okay. So this kind of things, we can have 4 kind of cases. The first is incomplete, noisy, inconsistent, and intentional. So it represents the dirty data. The first, incomplete. The data may be incomplete. The meaning by incomplete, it is lack attribute values. Maybe no attribute values. It has certain attributes of interest. It contains only the aggregate data, or we cannot get the detailed data. For example, you know, when you get a survey or questionnaire, maybe some people will ask you, what is your occupation? What is your job? But you do not want to say, so you keep it as blank. Then it is missing data. When you put it as blank, yeah, we don't have the data. It's missing. Noisy data. We call it noise or errors. Or sometimes we call it outliers. Let's say salary. The salary is -10. Is it possible? Yeah. Maybe the minimum of our salary will be 0. But if it is minus, then there will be error. So we can say this is noisy or this is error. Inconsistent. Contain discrepancies in codes or name. For example, age is 45. The birthday is January 1st, 2015. What is the inconsistency here? If the birthday is 2015, then until this year, the person will be 7 years old. Am I right? 2022 minus 2015, so 7. But the age is 45. Then it is not consistent. Okay. In this case, yeah, we need to do something. We need to pre-process. Or maybe a rating. We have the original rating is using 1, 2, 3, but now it changed to A, B, C. Then it is also not consistent. Intentional. is this guy's missing data. So let's say if you are visiting a mart, okay, if you go to supermarket, and if they ask you to fill in some data to be a member of that supermarket. So to make it simple, maybe they will ask only your name, your phone number, and then the other field will be blank. Okay. Because they do not know your birthday, the person intentionally put the birthday as January 1st. So all people will have the birthday January 1st because it's blank. So there can be something like this intention. Okay. So first, we will discuss the incomplete or missing data. What is the meaning by incomplete or missing data? So data is not always available. Many tuples have no recorded value for several attributes, such as customer income in sales data. For example, yeah. Do you want to share your income? If you get some income from a company, are you willing to share the income information? Of course, you will not share easily. Yeah? So that kind of data can be missing or not complete. Maybe, yeah, this kind of data is always not available. Other kind of problems of missing data may be due to the equipment malfunction, as I mentioned before, equipment errors, or inconsistent with other recorded data and thus delayed. Data not entered due to misunderstanding. Certain data may not be considered important at the time of entry. So maybe when you apply for a membership, the person think that it is not important to get your address. So it is empty or it is blank. Not register history or changes of the data. So maybe you already moved your original hometown, for example, Jeju, but you already moved to Yongin. So it's also like incomplete or missing. Missing data may need to be inferred. It means we need to understand the missing data so we know how to handle it. I will let you know 3 types of missing values. The first type of missing value, we call it missing completely at random, or MCAR. The fact that a certain value is missing has nothing to do with its assumed value and with the value of other variables. So it is completely at random. So we are not sure what are the patterns of the missing values. So the data is missing. Yeah, for example, it is due to the instrument fault. Or the data is missing due to the internet connection error. So it is totally completely at random. We are not sure what is the cause of this missing value. Let's say I have this complete data. And then I have this incomplete data. This is missing. 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 And this is missing. Let's assume that I know the complete data. And some of them are missing. If I check on this one, yeah, somehow the missing values are random. there is no pattern. So let's see the example, the second example. It is missing at random, MAR. Is the value of the missing data can somehow be predicted from some of other variables in the dataset. For example, data is missing due to connectivity in the rural areas. The rural areas, like Sigun. In the rural areas, maybe there is not a good internet connection, so we cannot get data. Or the income data is missing for respondents on certain ages and or gender. Maybe for younger people, the person who are less than 20 years old, they don't have any occupation, so the income is missing. If you look at this table, okay, let's say I have this complete data, and then this is the incomplete data. Can you see what are the patterns of the incomplete data? Is there any particular patterns here? Is there any particular patterns why the data are missing? Just at a glance, we can see that for the older, the data is available. But for the youngers, when the age is less than 40, the data is missing. Okay. Then there is a kind of pattern. Maybe the youngers, they do not want to share the IQ score. So we can somehow predict. Okay, the missing values is because of the younger people. Okay. Because this is missing at random. Somehow we can still predict. But we have missing not at random. MNAR is the most complicated one, both in terms of finding it and dealing with it. For example, data is missing due to the intention manner of driver A. Let's say you have a logistic company. Okay? You have a driver. Maybe you have some drivers. And then one driver, he always not giving the proper data, or he always forget to input the data. So we can, okay, I know that the driver A always put the missing value. Or maybe we know that the data is missing when the city equals to Surabaya. Okay, Surabaya is one city in Indonesia. Okay. So if there is a particular part that you can understand, then it is good. But sometimes it is difficult to find. Now let's see this table. Suppose I have this complete data, and then I want to check the missing values. Can you see any patterns of this? Is there any pattern? Okay, good. The data IQ score is missing when the IQ score is less than 110 or 105. Okay. So maybe the person who have low IQ score, they do not want to share the IQ score. So this kind of missing values is somehow a little bit complicated to find it. And if you can figure out the patterns, it will be easily for you to handle these missing values. Okay. So the assumption and the missing data mechanisms, okay. In most problems, the data is arranged in the rectangular data matrix, where missing values or MV can appear like this one. If you have only one column, it is easy to recognize. But when you have multiple columns, attributes, we call it the columns. Okay, we have 1, 2, 3, 4, 5, 6 until M. And instances, we call this is rows. Okay. And let's say the missing is here, 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 and here. So it is more complex. And it is difficult to find the patterns like what we did before. So we need to do something to check the patterns, or maybe we need to do something to handle the missing values when the missing values are a lot like this one. Okay, I guess I will stop here because of the time. Okay, I will continue again on Thursday. Any questions?